All right, so today we're looking at antiderivatives, or the idea behind a basic integral. When we're talking about antiderivative, we're talking about the opposite of the derivative. So we're thinking, what would we have to take the derivative of to get x squared plus 2x? So if we think about it, we would have had to pull the power down and subtract 1. So we'll add 1 to the power, so we'll x cubed. And we had to pull the power down, so we end up with 1 there. So it would have been over 3 plus, and then same thing here, we would have had to been up 1 in power, so x squared, and we would have to pull the power down, so we end up with 2 there, which would work. All right, so this was what we would say is our antiderivative. Say this is capital F of x. Now the issue is, this is not the only possible antiderivative, because there's something else we have to take into consideration. A constant. If we had plus 5, that would give us the same thing. If we had plus 100, that would give us the same thing. So anytime we had to do this, we also have to consider that there might have been a constant that was added there as well. Okay? This is the idea of an antiderivative. And we have a few things we use to describe these. The first thing is this symbol right here. This is the integral symbol. This is denoting a integral, or the antiderivative, or finding the antiderivative. This green right here is what we call the integrand. This is what we are actually finding the integral of. The dx is what variable it's with respect to. Which is, in this case, with respect to x. This over here is the actual antiderivative. It is the part that you actually undo the derivative for. And then the c is what we call our constant of integration. And all integrals should have a constant of integration as long as it's an indefinite integral. That's what we're looking at today. A definite integral is something that will come in the future, and we'll talk about it when we get to it. But for now, indefinite integrals are what we're looking at. So we need a general formula for this. Well, if we think back to what we did, we added 1 to our exponent, x to the n plus 1, and we divided by whatever that new exponent was. So divided by n plus 1, and then plus c. This is the general form of the antiderivative for a power rule. Now you'll notice when we go through this, we don't have quotient rule or product rule or chain rule. We will look at something in the future that's kind of like the backwards of product rule, and we'll look at something in the future that's kind of like the backwards of chain rule, but not really. It's kind of its own thing. It's not an exact opposite like we had here. Really, our base form that we're going to use for almost everything is this general form power rule. So we have some we can practice for, and in most of these, it's going to be the same idea. We're going to add 1 to the exponent, so 2 times x to the 5th divided by our new exponent, divided by 5, minus 3 times x to the 4th divided by 4, plus x to the 2nd divided by 2, minus 2x to the 1 divided by 1. But the big thing is, we always have to remember to add a plus c. So we have 2/5 x to the 5 minus 3/4 x to the 4th plus x squared over 2 minus 2x plus c. Now you'll notice I won't pull out common factors here because this is a polynomial we're creating and we don't know what c, and c is a constant, which means it's not actually a common factor if we pull it out because c may not have or won't have an x on it. All right, we can also do ones like this, where we can just change it to 2 minus 2x to the negative 2 and do the same process. Oops. So we have 2x minus 2x to the, add 1 to the exponent, so negative 1, divided by our new exponent, plus c. So 2x plus 2 over x plus c. Or we have ones like this, where we can simplify first. So it's going to be the integral of, that's x to the 1/2 over x squared, so x to the negative 3/2. And so add 1 to the exponent, x to the 5, or x to the, negative 1/2, divide by our new exponent, divide by negative 1/2, which gives us negative 2 over the square root of x plus c. Once again, this is a function we do not need to rationalize, so there's no reason to multiply by the root x over root x. The other thing we're going to talk about is the trig functions, which means we're just doing the opposite of the derivative. So if the derivative of sine gives us cosine, then the integral of cosine is going to give us sine. If the derivative of cosine gives us negative sine, then the integral of sine should give us negative cosine. The rest of these you have to be exact. So the integral of secant we don't know, but the integral of secant squared is going to be tangent. Now, all of these are still integral or indefinite integrals, so we should still have a plus c at the end of all of them. And then same for over here. So we could do integral of secant x tangent x dx is equal to secant x plus c. Integral of cotangent x dx, or sorry, not cotangent, negative cosecant squared. We'll do positive cosecant squared, just move the negative to the other side, is equal to negative cotangent x plus c. And then the integral of cosecant x cotangent x dx is equal to negative cosecant x plus c. And we can look at some practice of these. All right, so the idea is just doing the integral of each individual term. Integral of sine is negative cosine, plus integral of cosine is sine, 3 sine x, and then plus c. Okay. The last thing is going to be solving a differential equation. All right, this is not the full differential equations unit that we will have in the future. This is just the general idea. A differential equation is an equation which has been taken the derivative of. So in this case, we have f prime of x. That's saying f has been taken the derivative of. We use the solution in a way to find the original f of x. So the idea would be undo the derivative. Okay, easy enough. The integral of f prime of x, that undoes the derivative and gives us f of x. So we end up with the integral of x minus 3, which equals, dx, there we go, x squared over 2 minus 3x, but then we have a plus c. And this is where the second bit of information comes from. We call this bit of information our c finder. It helps us find c. We know that this equation right here represents f of x. So we know f of x has to equal x squared over 2 minus 3x plus c. So that means if we plug in 2, we should get 4. So 4 equals 2 squared over 2 minus 3 times 2 plus c. So 4 equals 2 minus 6 plus c. 4 equals negative 4 plus c. c is equal to 8. Now, c is not our answer though. The solution to the differential equation is. So our solution is the original function with c plugged in. X squared over 2 minus 3x plus 8. And there's our answer. Okay, here's another practice problem if you want to try it on your own. This one starts with the second derivative. So you have to do the integral once, then use this when you do the first integral, then do the integral again and use this for the second one. Okay? All right, with that, y'all let me know if you have any questions. Have a great day.